Hello friends, in this video we will learn how to use SAP 2000 to analyze this frame to get all the diagrams needed to design this concrete frame. To start with, all the necessary data are given here. Are the length of beam is 5.69 meters and length of columns is 3.05 meters. The cross section of the columns, both of them are 60 by 25, and the beam is T-beam. This is the section of it. So to start with, I will start by new model, then going to be sure that the units are kilonewton meters, then selecting 2D frame. Now number of stories are 1, and then base is 1 also, since we have only single story and single base. Then I will select the story height to be 3.05, as it is the height of the column. Now bay width will be 5.69 as it's given here, 5.69 meters. Now beams, I will add here a section, add a new property, I will say rectangular. Now for the beam section, the only thing that contributes into the self weight of the beam is this part. Actually, I will select rectangle and say red. This part, we can say yes. So this part will contribute into the weight of the beam. So we will define the beam as 50, since this is 10 and then 40, we have 50 by 25 centimeters. So I'll go to SAP, I will say 0.50 depth, then 0.25. Yes. Material is concrete, then we will change this one, we'll change the unit weight of concrete, but later on. Now concrete reinforcement, I will mention that it is a beam. Then I press OK. OK. Now OK. For the columns, we will add a new section, add a new property. I will say it's rectangular. Then I will say here it is column. Now the column is 60 by 25, so I will write 0.60 by 0.25. Then I'll say the material is concrete, then concrete reinforcement, it's column. Okay. So the columns is column, selecting this one. We'll say restraints and then portal. Okay, pressing OK. Yes, we are done with it. What is left is to change these supports to be fixed, since here it is mentioned it is fixed. So I will say assign joint restraints. I will make it fixed. Okay, this is fixed. Now what is left is to define materials, changing the unit weight of concrete to be, let's say this is C concrete, let's say concrete, and then I write it here 25. For the unit weight of for the modulus of elasticity, I will use it 30,000. 3 zeros and then 3 zeros again, since we are assuming it's concrete C25. Now make sure that this is C25, let's say. Okay, and then changing in the steel also, I will write here it is steel, make it 77, and then this one 2 times 10 power 8. That's it. Okay. Now what is left is to define load patterns. I will define load pattern live load, since we have a live load. Add a new combo, and then I will say EQ, since it's earthquake, EQ, and its type is quake, but don't assign any auto lateral load pattern, just leave it as it is. Okay. Now going to load combination, I will add multi combinations. So I'll say combination 1 will be 1.4 dead load plus 1.6 live load. Then I will add a new combo. I will say it is now 1 of the dead load, 1 live load, then earthquake. Okay. Now adding a new combination also, I will say now dead load and live load, then -1 for the earthquake, so it will be in the other direction. Adding last two combinations will be 0.9 dead load plus 1 earthquake. Pressing OK, then add copy of it. I will change this one to -1. Modify. OK. Yes, now we are done with all the combinations. What is left is to assign these loads on the beam and the column on the frame from that point. At this point we will assign the earthquake force. I will select this beam and I will say assign frame loads distributed. How much was the dead load? It was 29. So 29 for the dead load. Dead load, it's gravity, so I will say apply. And it's already applied, and then select the beam again and change it to live and assign 21. I will click apply. Okay, to make sure that the load assignments is correct, you press right click to the beam, and then here we can see all the loads, dead and live. Okay, what is left is now to select this joint and say assign joint loads forces, and I will select its type is earthquake. It's in X direction, positive global X direction, so it will be here 361. So I'll say 361 kilonewtons. Apply. Okay. Now to get rid of the forces, yes, now all the forces are existed. Now we can run the analysis and design of this. Actually, we will not design it by the software, we will design it manually, so only run the analysis. Now we can save frame, save frame. Yes, this is the deflected shape due to dead load only. Now we can change it. This is by earthquake, but we can see the combination 1.4 plus 1.6 live load. This is by earthquake to the positive X direction. This is by earthquake negative X direction. This is only dead load plus the earthquake. This is only dead load plus minus the earthquake. Yes, but now what do we need is to see all the moment diagrams. Let's say moment, this is combination 1. I'll set show values and apply. Yes, it's clear here. Can zoom in. So the maximum value in positive is 137, and then the negative is 180. If we go to the next one, you'll see here it's 129, but negative 297 in the combination, in the next combination, which is the plus earthquake. So, and here it is for the other side. Also, we have 300 and 301 or something. We can change the scale. We can set 0.0044. Yes, it might be more easily. Yes, to see it. Yes, now it's easier. It's 301.02. Yes, these are all the results. So we can see the highest one in positive is in 1.4 plus 1.6 load combination, it's 137, and in the other combination plus the earthquake, it is highest one is negative 297. The negative one here is higher than the negative here. So we can design the beam for this negative value, and then design also for this positive value, but it will be more safer to design the positive reinforcements according to this load combination for the positive reinforcements. So that's it for these diagrams. We can select shear 2 as well to see the shear forces on the column and the beam, and then change the load combination. This is 1.4 plus 1.6 since it's combination 1. This is the other combinations also, so they are near to each other since it's one of them. This one combination 2 it's plus AQ, this one is minus the earthquake. So, and we can also select the axial force since we will design the column for it. This is the axial force on 239, so here we have it 224, then 224 for this one. So we can see the higher one is in the 1.4 plus 1.6 combination. That's it for this tutorial. We can now also print the graphics and we can then design the column. This is for SAP 2000. For the design of column, we can take this value 239 as a normal force on the column. I will say N is equal to 239 kilonewtons, let's say. Then yes, kilonewtons. Then I will say the moment is equal to how much was the moment on the column is, let's check it. Here it's 180, here it's bigger than the other one, so we can see the highest one is 433. Let's say 434 kilonewtons. Yes, so these are the moments. Then we can calculate the we can say N over BH times FCD, then the other one BH squared times FCD, and then calculate them to go to the diagram. Then that diagram in the notes that it has these values. Yes, it goes like this in all the things. So I'm choosing the rho TM, calculating the rho TM, and then we are done. Thanks for watching. If you have any questions, I am ready to reply for all your questions and all your problems. Wish you all the best.